Evet hocam, başlayabilirsiniz.
Herkes tam mı? Şu an ben göremiyorum ama.
Evet, birinci sunum yapan var burada listede.
Mohammad Razeq is the first presenter, I think, right? You are here. And the second one is 2021, Abdulwahid Rahnavard. Is he here? No? 2024 is here, paper
Yes.
ID. 2029, Bora Doğaroğlu or Pelin Çalışkanelli is here. I think no. 2037 from Malik Zada. No. And final, this is our paper with my graduate student, but I think he is not attend. Okay. First, me introduce myself first, then we can start it. I am Oruç Altıntaşı from İzmir Katip Çelebi University, Department of Civil Engineering. I am head of the Transportation Engineering Division. Today, all participants, I think CI 2037 is attended. Okay. For this session, every presenter have 15 minutes, okay? But this 15 minutes includes both the presentation and question answer part. So, I suggest you to finalize your presentation within 12 or 13 minutes. Then we have 2 or 3 minutes for the question part, okay? First, welcome all of you. And if you are ready, we can start from the first paper. Potential application of AASHTOWare pavement ME design 2.5.5 software for pavement design in Turkey. The presenter is Mohammad Razeq Shakhan. Yes. You can start.
Welcome to my presentation. My name is Mohammad Razeq Shakhan, PhD student in Civil Engineering Transportation at Yolu University.
Sorry, we can't hear you. I can't hear you. Please, loudly.
Do you have my house, my voice?
Ses gelmiyor değil mi? Sadece ben mi öyle, bana mı gelmiyor? Siz duyuyor musunuz?
Hayır hocam.
Gelmiyor.
Gelmiyor.
Duyuyor musunuz?
Şu an tamam.
Tamam, ama biraz yükselt sesini.
Welcome to my presentation. My name is Mohammad Razeq Shakhan, PhD student in Civil Engineering Transportation at Yolu University. I'm from Afghanistan. The presentation title is Potential Application of AASHTOWare Pavement ME Design for Implementation in Turkey, or for pavement design in Turkey. Let's start with context. What is the AASHTOWare Pavement ME Design or Mechanistic Integral Pavement Design Guide? What is the required local data to apply this method, and how to apply local design data in this program, and how to use software for pavement design, and how to conduct optimized pavement design, and finally, how to conduct local design and local collaboration of the mechanistic empirical pavement design guide or AASHTOWare pavement ME design. So, what is AASHTOWare pavement ME design or mechanistic empirical pavement design guide in 2004? This method was established or developed In 2008, the American Association of State Highway Transportation Officials implemented this method. In 2008, also, in the same year, the whole pavement method was transferred to the software that is called Darwin ME Pavement Design. In 2013, the commercial version of the software was released for all studies. And what does do the AASHTOWare or Mechanical Integral Pavement Design Guide? This method predicts various pavement distresses like rutting and cracking. So here is a question: what is rutting and what is cracking? And pavement. Let's look this one. Here is photos from a road in Turkey in Adana. It is we are looking the cracks, the types of cracks in this road, and also this road. This is called distress and roads, and this also this is rutting. So the Mechanical Integral Pavement Design Guide can predict this type of distresses. So countries, including Turkey, want to implement this method. So how to implement this method? The implementation has two parts: part 1 or part A and part B. And part 1 is including local data collection and conducting sensitivity analysis, evaluation, local calibration and validation. And part B, determination of pavement performance threshold values and selecting reliability levels. We will talk about these steps, how to conduct these steps, and what is these steps. Required data. The Mechanical Integral Pavement Design Guide extensively required traffic data, such as basic traffic information, including general information, initial two-ways, and others, and traffic volume, adjustment factors, request vehicle class distribution, traffic growth factors, multiplication factors, and hourly distribution factors. Also, traffic data including axial load distribution factors, single axial load, tandem axial load, tridem, and quad axial load in different load categories and load intervals for single, tandem, tridem, and quad axial. Also, general traffic inputs including axial configuration, lateral traffic wander, and so on. Also, this new method, it requires how the climate data, including temperature, wind speed, sunshine, precipitation, humidity, and water table. This data is suggested to be the whole year of pavement life, design life. Also required local data, including material properties, asphalt material properties, mixer volumetric, mechanical properties, and thermal properties. Also general material and subject properties, resonant modulus, coefficient, lateral earth pressure, and Poisson ratio. And asphalt concrete, including mixture volumetric properties like air voids, binder content, Poisson ratio, and so on. And dynamic modulus, aggregate gradation, and temperature reference, and asphalt binder, and also indirect tensile strength and creep compliance. So when we collect this data, how we can apply in software? Local data should be analyzed. If there be any difference between Mechanical Integral Pavement Design Guide format and local data, they should be converted to the Mechanical Integral Pavement Design Guide. So how to convert? For example, the climate data should be written in this HCD format like this. And I did this one for Chile, Hawalimani. Should be written in this file that software can recognize this file. Vehicle class should be done something like this. The default is up to 13 class, start from 4, but in Turkey, which is up to 10, that I did this one for Turkey, I classified. Axial load distribution factors, and number of axial per track is something like this for single, tandem, tridem, and quad. We don't have quad in Turkey, only have up to tridem axial. And major pavement distresses, the unit of pavement distress should be the same as Mechanical Integral Pavement Design Guide that we can use. Otherwise, we should change that one too. So, how we can, when we collect our data and convert to the Mechanical Integral Pavement Design Guide format, we can apply or insert in the software. The left part shows our activities. This part shows the pavement sections and pavement layer types and materials. When we choose every layers, the material properties is shows here. We can change and put our data. This part shows the pavement type. We can choose our pavement and design life and so on. Here is as the distresses and threshold values and reliability and what pavement.
Mohammad, sorry for the interruption. Sorry. Could you please speak loudly? We can't hear you.
Do you have my voice now? Maybe my connection is not good. I don't know.
Okay.
Now is okay?
Please continue.
Okay. Here we have the pavement layers, 3 layers of AC layer or asphalt concrete layers and other layers. So when we insert our these material properties and pavement sections, we come to traffic. Here the vehicle class and distribution, and here the monthly adjustment factor, axle part track and others ADTT. We can insert all of data. We come to climate data. How we can insert our climate data in software. First of all, that software can recognize that I did for Izmir here. This shows the climate data for these places, which we come to run and paste our local data, climate data here, and open the custom files section, and we write this code that the software can recognize our climate data. And finally, we come to here and click this one, and finally we can select one of our place that you want to design pavement, and we come to select climate will be selected. And here we can insert our water table, and finally the climate data appears something like this in software. It is including temperature, wind speed, sunshine, precipitation, humidity that I did from 2014 up to 2018 for Izmir. And when we insert all our local data to software, we run our pavement. Pavement will run. When all of them be green, it means the analysis is done. So the output of design is this. We have predicted distresses, rutting and cracking and IRI. So the pavement design is okay when the predicted be lower than targeted that we give to program. So for example, for rating, AC rating, it is field. Why? Because it should be 6 millimeter, but predicted 6.32. So this is when the pavement will be filled in 17 years. Pavement will start to be filled regarding to AC rating. So now how we can solve this problem in this software? It is called optimized pavement design. So another question is this. For example, for IRI pavement is okay, for rating is okay, for thermal cracking is okay, but for bottom up or alligator cracking is not okay. In this place, it is exit from threshold value. So what we do and how we can remove this one. So first we should, a designer should know about the behavior of design inputs. So by conducting sensitivity analysis, we will know. So in this particular problem, by decreasing this aggregate gradation and increasing this aggregate gradation, we can remove this one. Look, here we did this one. And to apply optimized design, to do optimized design, we should know about behavior of material properties, something like this. For example, binder content has this effect on pavement performance. If B5 too much, up to 10, after 10, so the binder content will be more than 10%. It means it has no any effect after that. So the other part is local collaboration. What is local collaboration? We talk about this one. We collect pavement distress from fields from a specific pavement segments. So the predicted should not be more or should not be lesser than actual distresses which we measured from field. It should be equal or so close, too close. So that time it means that this program can work properly. Otherwise, if there any difference between predicted and measured distresses, so it means this program will not work. So in this purpose, we should remove this difference between predicted and targeted or measured distresses. It is called local collaboration. Local collaboration means to remove the difference between predicted and measured distresses. So how we can remove this one? By adjusting these factors that I did. These factors are called local collaboration factors. For each distresses, we have one formula. So we adjust until the bias and standard error removes. So if doesn't work, we should develop new formula. So how we can do this one? By software, we change our local collaboration factors. When we achieved, we save, and after that, the software is ready to be used for payment, analysis, and design. The final step is selecting threshold values and reliability that I summarized for freeways, interstate, and secondary road, and also reliability for freeway should be 95, for interstate be 90, and for secondary 85. And this is the threshold values. For example, for alligator cracking, 10%, 20%, and 30%. So what is the effect of this one on pavement thickness and pavement cost? I show one example here. For example, for 85%, this one, 85%. And for 95%, this one shows almost 0.3 cubic meter asphalt. But for maybe 95%, and this requirement for ratting and cracking, so we need to spend how much asphalt? 0.9. So it means that the selecting threshold values and reliability level has so much effect on pavement cost and pavement layer thicknesses. Thank you. If there is any question, I'm here.
Thank you, Mohammad, for the nice presentation and the comprehensive work. Are there any questions for this presentation? No? If not, let's skip to the next paper, which is Link Performance Function for B-Model Urban Road Network, a case study of İzmir City by Abdulrahman.
Professor Altıntaşı, he called that he will not attend.
Thank you, sir.
Let's skip to the next one. He is ready.
Okay. Initial planning for feeder bus roads using multiple traveling salesman problem based on genetic algorithms by Abdulrahman. Yes.
You are welcome to this presentation. My name is Hassan Shoaibu Abdulrahman. I'm a graduate student in Dokuz Eylül, and my supervisor is Associate Professor Mustafa Özuysal. The topic of my presentation today is initial planning of feeder bus routes using multiple travel salesman problem-based genetic algorithm. So for us to run through our discussion, I'll try to give a brief description about bus route network design.
Can you please make the presentation full screen?
Okay. The topic of my discussion today is, I'll run through the discussion by first giving an introduction, the problem statement, a brief description about bus route network design, multiple travel salesman problem, genetic algorithm. Then I'll talk about algorithm that is used to design our feeder bus routes and that's all. So when we have increased mobility, some traffic problems evolve, like traffic congestion, air pollution, and accidents, and other problems such as reduction in public spaces and lead to social exclusion. So transportation experts agree that mass transportation is the answer to a sustainable transportation system. A look at this picture will give you an idea. Look at the area occupied by personal mobility. It is the same area. It is much lesser when you consider using mass transportation. So transportation experts agree that mass transportation is the solution. However, a case of Izmir, for example, who has multiple mass transportation systems like the Esot bus, the Vapur, the Isban, and so much more. These mass transportation systems have different characteristics, and hence they serve different purposes, which creates another problem. How do we integrate this transportation system? So the aspect of transportation planning that is related to designing this type of system is known as transit route design. A look at this figure, for example, let's assume these nodes represent bus stops. So if we are to design a bus route network design, we try as much as possible to connect this node in the form of a network. Now, this problem is termed as bus route network design, and this does not accommodate different kinds of mass transportation system like I earlier mentioned. So another type of bus route network design is the feeder bus route network system, whereby you have a rapid system, maybe like metro, for example, and these nodes represent bus stop. So we now try to connect a mass transit system to new feeder bus route system. This will be an introduction into intermodal transportation system. So from our own literature search, we discovered that the feeder bus design problem is similar in formulation to traveling salesman's problem. Now, in traveling salesman problem, it involves a number of cities. Say, for example, 1, 2, 3, 4, we have 8 cities. And the traveling salesman will try to visit all the cities once and return to the depot. So the problem tries to find the minimal distance a traveling salesman can travel all across the cities, visiting them once. So this problem is actually very difficult to solve mathematically, because if we want to use the search algorithm to find it, it may take number of years to solve that type of problem. So the only way to solve this type of problem is to use a heuristic algorithm like genetic algorithm. Now, genetic algorithm is a stochastic-based algorithm which tries to mimic the way genes are selected to give the best gene. So genetic algorithm will be very useful in selecting that type of problem. So combining both now, the multiple travel salesman problem and genetic algorithm. The algorithm goes this way. We have a fixed center, which may represent our train station. Then we have other nodes, which may represent our bus stops. So what we try to do is to design feeder bus routes that will visit all other stops once and return back to the said node. Now, the picture you are seeing here represents 5 different types of routes, which represent 5 different salesman's problem. So we took an example from the TSP library. to get the coordinates to represent our station and our stop. And we try to use our algorithm to solve it. First, we need to find the distance between all the stops and all the nodes. And this is the distance matrix in Euclidean form. Then we run our algorithm. For two Salesman solution, the distance matrix shows the distance between all the nodes. And this is the best solution, showing a convergence in optimization. This is for second two Salesman's problem. And this is for third Salesman's problem. All the solutions converge. Similarly, we have for 4 Salesman's problem and 5 Salesman. All, as you can see from here, the more we increase the number of salesmen, the more the yellow patches increase, showing that the longer the distance. So from our algorithm, this is our route structure for one salesman. All routes are connected and they are only visited once. The second one is two salesman's problem. Now we have two different routes, the red one and the blue one. We keep increasing the number. This is 3 salesman's problem, and the total distance keeps increasing. Total distance keeps increasing up to the last one. So we now calculated the operating cost for each example, for 1 salesman, 2 salesman, 3 salesman, 4, 5, and the cost kept increasing as we increase the number of salesmen. Now, the best known TSP solution is given up as the red colored option. Our algorithm was able to find very close to the TSP solution. So in essence, in general, we can conclude that the multiple travel salesman's problem is similar to feeder bus route network design problem. And it is a logical way to plan feeder bus routes based on shortest distance between fixed nodes and other nodes. Now, the different solutions may be used to design different types of feeder bus routes. For example, the two-route solution can be used to design a suburban feeder bus route, which connects city center with suburban regions using longer routes. Now, as a recommendation, we recommend that a multi-objective optimization be done, since transit problems does not only require the operator's perspective, but also the user's perspective and even social cost. Thank you. These are my references. Thank you.
Thank you very much, Abdulrahman, for your nice work and sharing your studies with us. Any question for this presentation? Any question? Let me ask one question.
Okay.
Did you perform your algorithms for the İzmir case?
No, I took a TSP, it's a known library that has coordinates. The coordinate I took from the United States. But after I test the algorithm in my own research, I'll have to apply it in the case of İzmir, using İzmir coordinates.
Thanks. Thank you very much. If you don't have any question, then I want to skip the next paper, which is Evaluation of Intelligent Transportation System Effect on Parking Lot Preferences by Bora Doğaroğlu.
Yes, thank you. First of all, I want to introduce myself. Can you hear my voice? Is it clear?
Now it is good.
Okay, let me first introduce myself. I'm a research assistant in İzmir Institute of Technology for 3 years. working on in civil engineering department, working on transportation. I'm also a PhD student in the 9 Eylül University, especially studying on intelligent transportation systems. Now I will make a presentation we have done with Pelin Çalışkanelli, associated prof and advisor of mine. Let me share my screen first. This one, I think. Okay. I think it's clear now. The name of the study, can I hide it? Okay. The name of my study is the evaluation of intelligent transportation system effect on the parking preferences. First of all, I have to make an explanation about the content of the study. I will start with introduction, then the introduction followed by the methodology that we use for our studies. Then we created some scenarios for our studies. According to those scenarios, we get the results from simulation and I will make a result and analysis discussion. Then I will conclude my study with a general discussion. To make an introduction to my study, all of us know that every city is trying to be a smart city nowadays, especially the developing cities, increasing demand of the traffic. Cities are trying to be a smart city to enhance the quality of life, converse the electricity, or the minimize the pollution. A part of the smart cities is the intelligent transportation system that solve the problem of the increasing traffic demand, especially in the developed and developing city centers. IPGS is the intelligent parking guidance system, is the part of also the sub-part of the intelligent transportation system, take care about the parking place optimization by guiding the drivers using a real-time data to the parking lots as they taking a consideration on their preferences of the parking lots. IPGS also will be simulated by the agent-based and the multi-agent-based simulation programs to make the optimum usage of the parking lots according to parking drivers' preferences on the parking lot. NetLogo is a simulation program, a multi-agent-based modeling simulation environment that is the simulation by writing your own codes in any social or engineering problems. So in this study, we use a NetLogo simulation environment to write a multi-agent-based model simulation. Aim of this study to investigate the effect of IPGS systems, intelligent parking guidance system, on parking preferences to enhance the capacity of the capacity utilization of the parking lots. To do that, we propose two models. One is representing the conventional system, first model representing the conventional system, and the other one is representing an IPGS model we proposed for this study. First model, also we create 5 scenarios for these two models. We generate multi-agent based simulation program in NetLogo and make a simulation for 5 scenarios for these two models. First models, as I said, it represents the conventional system. Drivers choose parking lot according to the closest parking lot, and they prefer the parking lot according to driving distance, in other words. And the second model, and a created IPGS model, proposed IPGS model, the system IPGS system direct the drivers according to the occupancy of the 3 parking lots. We use 3 parking lot scenarios, and we create a 3 parking lot environment. So we model the simulate the 2R models according to those 3 parking lot preferences. The simulation results of 2 models is compared in terms of the occupancy to illustrate the efficient utilization of the parking infrastructures. As I said, there was a two model to briefly explain. First model represents conventional system. The other one is the IPGS system, Intelligent Parking Guidance System. In the model one, drivers direct your crews according to their perception, according to the closest parking lot. They prefer the distance advantages of the driving. And in model two, and guidance done by the Intelligent Guidance System, IPGS, according to occupancy condition of the three parking lots. This is the interface of our program developed in NetLego to simulate parking preferences. This is developed in my thesis, in my Master of Science thesis. There are lots of preference parameters in this program, but we will just use the driving distance or and the parking availability situation to simulate first of all the commercial system and the second for the IPGS system. Degree of availability that we use for the commercial IPGS system will be calculated in two formulations in the simulation program. The first right-hand side, there is a mean time between arrival formulation that find the mean time between incoming cars. So by this value, the availability of the parking instantaneously will be calculated. So the parking simulation program will be making preferences according to the instantaneously calculated degree of availability of parking lots. This is an illustration of our scenario. There is three parking lots starting from right hand to left-hand side. The first parking lot and second and third one. As you can see, the first is closest according to the cruise startup point with a distance D1. D1 is equal to 1 kilometer for this study. And a D2 is for the second parking lot is selected as 1.5 kilometer. And the third parking lot is far away from the starting point, about 2 kilometers. And also the parking lots capacity selected at about 250 units for each parking lot. Different startup occupancy each simulation is accepted. For each 5 simulation for both two models, the startup occupancy of the parking lot at the beginning of the simulation is different. Also, no vehicle leave the parking lot while the simulation conducted. We accept that no vehicle leaving the parking lot. In model 1, we accept that no information warning signs around the parking lots on the cruise distance. Also, in model 2, we accept that drivers directed by the IPGS system and all the drivers use the IPGS system. This is our 5 different scenarios with according to the parking lot occupancy. Also, total arrival number will change according to the capacity of the both 3 parking lots. As you can see, the first one is empty at the beginning of the simulation. All the parking lots is empty. In the second one, only the first parking lot is have units inside the parking lot. Also, different situations are created for understand the different effects of IPGS according to the conventional system. Results show us that IPGS balance the capacity usage of all parking lots in comparison to the conventional system. The usage of the parking lots are balanced by using the IPGS system. Also, the driver tend to fill up the first parking lot in conventional system, whereas the equilibrium state occur among all parking lots in IPGS. Those are the results screens in the simulation programs. Left-hand side shows the conventional system results, and the right-hand side also the IPGS system. The graph y-coordinate is the occupancy ratio. Graph drawn with respect to the occupancy ratio to the time. As you can see, the left-hand side, the conventional system, the first parking lot rapidly fill up with the parking preferences, and then the following, the first parking lot, the second parking lot sharply increase the capacity, its capacity, whereas the third parking lot is empty almost. But in IPGS system, they cooperate each other and they converge the same point at the occupancy ratio approximately. As it shows that the capacity usage of the three parking lot can be balanced by using the IPGS system. Also, the second simulation, third simulation, and fourth and fifth simulation gives this similar result for our study. This is the average capacity utilization of the parking lot in bar percentages. As you can see, the dark bars represent conventional results, and the light bars represent the IPGS system. For the first parking lot and the second parking lot, as you can see, the dark conventional bars are reach the capacity in the average capacity utilization of parking lot. And the third one, whereas, is at the 66% of its capacity. That means the first two of is fill up with the parking by the cars, but the last one is empty almost. But conversely, when we look at the IPGS system, the values for the capacity usage of three parking lots change between 86% and 91%, more balanced according to the conventional system. To briefly explain my study, 5 simulation of the two model, M1 and M2 representing conventional and the IPGS system simulated. Multi-agent-based simulation program is used to simulate all those simulation. We have making a comparison between IPGS and conventional system in terms of capacity utilization. The conventional system, in the conventional system M1 model, we saw that the first parking lot and the second one fill up respectively, but the third parking lot, only they fill up with 66% of its capacity. It will result the increase of the searching period because the drivers tend to go to the first parking lot, but they cannot find every time the place, and they have to search in parking lots for free parking places. If they could not find any place in the parking lot, they direct their crews to the second parking lot. They will also search some parking places in there. If they could not find even in second one, they have to go to third one. This will increase the parking search period. That the increase of the parking search period may lead to the waste of time, redundant fuel consumption, and excessive emission of the harmful gases. Whereas in the proposed IPGS model, in Model 2, capacity utilization is balanced between 86 and 91%. This will raise the probability of deducting a free parking place of a driver. Because in 3 of the parking places, there is also free parking place for newcomers or doesn't using the IPGS system. So we can say that IPGS benefit in the utilization of parking lot capacities and increase the probability of finding vacant spaces. That's for all of my study. If you have any question, I will answer. Thank you for listening.
Thank you very much for the nice presentation and sharing your work with us. Any question for this study? Question? I have one question. As I understand correctly, you are performing a simulation-based studies and developing a model.
Yeah.
My question is, I am considering the İzmir case where the high traffic demand exists. Is your model can be efficient?
Yes, of course, because in my thesis, I was making a case study, especially in the center of city, in Alsancak district. We used 3 car park lots at the center of the İzmir. We take the data from the IPGS system of the İzmir, İzum, we incorporate those data and make our simulation according to those data. We make a validation of our program according to those data. The program can simulate the same results with the data we observed from the IPGS system of the İzmir. So we say that the validity of the program is enough. So we develop much more advanced IPGS system for different parking preferences of the drivers. We make a simulation according to those preference parameters, and we got a good
real
result.
data.
Yeah. For this study, we just only make change the situation of the parking preferences. In my thesis, we didn't make the conventional system. For this study, we checked also the conventional situation and compared it with the IPGS system that used in the İzmir also for the 3 parking lots, similar with my thesis.
Thank you.
I am also thankful.
If you don't have any question, then the next presenter Mehmet İhsan Pekdemir. Kent içi çok şeritli yollarda araç takip aralıkları dağılımlarının incelenmesi Ankara Eskişehir yolu örneği.
Merhabalar hocalarım, merhaba arkadaşlar. Öncelikle ise kendimi tanıtayım. Ben Mehmet İhsan Pekdemir, inşaat mühendisiyim. İzmir Katip Çelebi Üniversitesi'nde İnşaat Mühendisliği Anabilim Dalı'nda yüksek lisans öğrencisiyim.
Pardon hocam, pardon. Onun önceki var burada listede gözüküyor.
Diğeri geoteknik alanında olduğu için ulaşımları bir tutalım. Geotekniği sonra hani bölünmesin diye bu şekilde yapmak istedim.
Tamam hocam. Teşekkür ederim.
Danışman hocam Oruç Altıntaşı. Öncelikle herkese sağlıklı günler diliyorum. Bu kongre kapsamında size yapmış olduğum çalışmanın sunumunu yapacağım. Şimdi şeyde bir sorun yok değil mi hocam? Sesim geliyor.
Geliyor.
Tamam. Yapmış olduğum çalışma kentsel çok şeritli yollarda araç takip aralık dağılımlarının incelenmesi. Ankara Eskişehir yolu örneği çalışmasını sizlere sunacağım. Bu sunum kapsamında öncelikli olarak bir giriş kısmım var. Çalışmanın kapsamı ve amacı, literatür çalışması, çalışma alanından bahsedeceğim, yöntem, verilerin analizi ve son olarak sonuçları karşılaştıracağım sizler için. Öncelikle arkadaşlar, araç takip zaman aralığı birbirini takip eden iki aracın belirlenmiş bir test noktasına varması arasında geçen süre olarak tanımlanıyor. Yani tanım olarak bu şekilde. Araç takip aralığının doğru modellenmesi, trafik güvenliği, yol hizmet seviyesi, farklı yol tipleri için yol kapasitesi, sürücü davranışları ve ulaşım sisteminin kapasitesini etkileyen bir trafik akım özelliğidir. Bu nedenle bu farklı trafik koşullarında trafiğin doğru model dağılımlarının analiz edilmesi büyük önem taşımakta. Daha önce yapılan çalışmalarda araç takip süresinin istatistiksel olarak modellenmesi birçok çalışma yapılmış. Bu çalışmalarda işte araç tipleri, işte otomobil mi, kamyon mu, işte otobüs gibi farklı araç tipleri üzerine, bunların etkileri üzerine çalışmalar yapılmış. Araç takip tipleri üzerine yapılan çalışmalar var. İşte otomobili takip etmesi, otomobilin kamyonu takip etmesi ve bunun gibi farklı araç tiplerinin araç takip süresi, farklı araç tiplerinin takiplerinin araç takip süresi üzerine etkileri incelenmiş. İşte farklı yol tiplerinde yapılan çalışmalar var. Kentsel arterlerde ve otoyollar üzerinde yapılan çalışmalar ayrı ayrı kıyaslanmış literatürde. Farklı trafik koşulları altında yapılan çalışmalar var ve sürücü davranışlarının araç takip süresine etkileri incelenmiş. Bunlar işte o bölgeyi bilen sürücülerle o bölgeyi bilmeyen sürücülerin takip süresine ne tarz etkileri var? Bu tarz çalışmalar yapılmış daha önce literatürde. İşte bu yapılan çalışmalardan bazıların şekilde işte listeli var bazıları. İşte burada birçok istatistiksel model önerilmiş. Yani her çalışmada farklı istatistiksel modellerin doğruluğu sonuçlarına ulaşılmış. Bunlardan bazıları işte 2014 yılında Tayland'da kentsel arterlerde yapılan çalışmalarda geri dağılımının daha uygun yakın sonuçlar verdiğini belirtmişler. Onun haricinde mesela 2014'te Singapur'da yapılan bir çalışmada kentsel arterler üzerinde yapılan çalışmada log normal ve Ingalls dağılımlarının araç takip süresi üzerinde doğru sonuçlar verdiği, yakın modeller oluşturduğu sonuçlarına ulaşmışlar. Mesela 2019'da Hindistan'da otoyollarda yapılan bir çalışmada da exponential ve Erlang dağılımlarının yakın sonuçlar verdiği sonuçlarına ulaşılmış. Ben kendi çalışmam kapsamında işte kent içi çok şeritli ana arter üzerinde orta şeritte seyir halinde olan araçların takip aralıklarının dağılımının farklı trafik koşulları altında inceledim. Bu kapsamda parametrik ve parametrik olmayan istatistiksel modelleri kullandım. Bunların modelimin uyumlu olup olmadığını araştırdım ben kendi çalışmam kapsamında. Benim çalışmamın yapmış olduğum çalışma işte sol tarafta belirtmiş olduğum haritada Ankara Eskişehir yolu ana arteri üzerinde bir çalışma yaptım. Sağ tarafta almış olduğumuz işte video kaydının çok küçük bir kesiti var. Şimdi ben burada yapmış olduğum çalışma kapsamında öncelikle zirve olan saat, yani trafiğin yoğun olan saatlerinde saat 7.30 ve 8.30 saatleri arasında ve zirve olmayan saatlerde, yani daha trafiğin daha sakin olduğu saat 10 ve 11 saatleri arasında bir video kaydı aldım. Ve bu almış olduğum video kayıtlarını geliştirmiş olduğumuz MATLAB kodu yardımıyla trafik verilerini analiz ettim. Bu çalışma kapsamında yöntem olarak elde etmiş olduğum verileri öncelikle kapasitesinin yolun kapasitesinin belirlenmesi için işte trafik akım modelleri ve kapasitesinin belirlenmesi konusunda 3 farklı model kullandım. Bunlar Greenshields, Greenberg ve Nordwesten modelleriydi. Bunlar burada kullanmış olduğum modeller sonucunda ben kapasiteyi her bir model için, her bir önerilen model için farklı kapasite sonuçlarına ulaştım ve burada Nordwesten modelinin daha önce yapılan çalışmalarda benim çalışma alanım olan işte kentsel Ankara Eskişehir yolunda daha iyi sonuç verdiği birçok çalışmada bunlar belirtilmiş. Bundan dolayı ben Nordwesten modelinden bulmuş olduğum kapasite değerini aldım. 2197 araç, saatte 2197 araç kapasite değerini kullanmış olduğum çalışmamda. Daha sonra burada MATLAB kodu yardımıyla elde etmiş olduğum verilerimden farklı trafik koşulları altında takip aralıklarını çıkarttım. Burada işte elde etmiş olduğum verilerden verilerin tabloların bir kısmını aldım. Yani çok fazla veri olduğu için hepsini buraya koymam olmayacaktı. Burada hani farklı trafik koşulları altında hacim bölü kapasite oranlarını buldum. Burada her dakika için geçen araç sayısı, örneklem sayısı ve bunların trafik takip aralık değerleri var. Şimdi burada öncelikle zirve olan saatler 7.30 ile 8.30 arasında yapmış olduğum çalışmadaki tablodan bir bölümü var burada. İşte burada göreceğiniz gibi hacim bölü kapasite oranı 1'e çok yakın, yani 0.9 ve 1 seviyelerinde, yani tam kapasitede çalışıyor aslında yolumuz burada. Burada her dakika için elde etmiş olduğum verilerim var tablo halinde. İşte mesela 7'yi 46 geçe 35 araç olarak ben örneklem saymışım. 35 araç geçmiş ve bunun işte tam kapasitede çalıştığını, az önceki Nordwesten 2109'du akım verim bulmuş ve kapasite oranım. Burada görmüş olduğunuz gibi 2102 araç. Sonra yoğun olmayan saatlerde benim hacim kapasite oranlarım işte saat 10 ile 11 arasında yapmış olduğum video kaydından elde etmiş olduğum verilerde işte kapasitenin yani hacim bölü kapasite oranının 0.6 olduğunu, daha az yoğun saatlerde farklı trafik koşulları altında veriler elde etmiş oldum. Daha sonra üçüncü olarak 5 adet ben istatistiksel dağılım seçmiş oldum. Bu aşamada 5 farklı parametrik ve parametrik olmayan istatistiksel modellerin uyumluluğunu Kolmogorov-Smirnov testi yaparak inceledim. Burada 4 tanesi parametrik dağılımlar bunlar. Bir tanesi Bur dağılımı, log normal dağılım, gamma dağılımı ve Weibull dağılımı. Bir tane de parametrik olmayan Gaussian dağılımını seçtim, 5 adet. Burada bu dağılımları seçmemdeki sebep işte literatürde birçok dağılım öneriliyor. Ancak hani bu dağılımlar daha fazla sıklıkla önerilmiş yollarda. Benim yani çok şeritli yollarda. Daha sonra bu modellerin, bu dağılımların yani yakın uyumluluğunu test etmek için işte KS testi, Kolmogorov-Smirnov testini kullandım. Bu Kolmogorov-Smirnov testi belirli bir dağılıma sahip verilerin bir popülasyondan gelip gelmediğine karar vermek için kullanılıyor. KS testinin genel formülü şekildeki gibi. Bu kapsamda işte elde etmiş olduğum verileri daha sonra işte olasılık yoğunluk grafikleri, PDF, İngilizcesi probability density function grafiklerini çıkarttım. Burada her bir farklı trafik koşulları altında, yani farklı hacim bölü kapasite oranlarında her bir dağılımın benim verime, yani şurada grafikte görmüş olduğunuz benim gerçek verim, burada renkli olarak göstermiş olduğum grafiklerde işte her bir dağılımın ne kadar iyi fit edip fit etmediğini görsel olarak burada kıyaslayabiliyoruz aslında. Görmüş olduğunuz gibi işte buradaki Bur, Gaussian, gamma ve log normal dağılımın yakın sonuçlar verdiğini, burada daha iyi fit ettiğini, ama Weibull dağılımının işte 0,5 için bu geçerli. Yani çok iyi fit etmediğini görebiliyoruz bu grafiklerden. Yine aynı şekilde diğer hacim bölü kapasite farklı trafik koşulları altında olan grafikleri de karşılaştırdığımız zaman burada Weibull dağılımının benim verilerime doğru, yani yakın fit etmediğini görsel olarak görüntüleyebiliyoruz. Onun haricinde burada non-parametrik olan Gaussian dağılımının işte burada mesela şurada 0,5 için yani çok fark edilebiliyor. Burada veriye daha yaklaştığını, işte burada oluşan verideki grafiğimdeki veri farklılıklarında Gaussian dağılımının ne kadar iyi fit edebildiğini görüntüleyebiliyoruz. Özellikle 0,9 hacim bölü kapasite oranında iyi sonuçlar verdiğini görüntüleyebiliyoruz. Onun haricinde genel olarak buradaki dağılımlarının benim istatistiksel yani benim verilerime yakın ettiğini görsel olarak burada grafiklerle görüntüleyebiliyorum. Daha sonra kümülatif dağılım grafiklerini çıkarttım. Burada CDF grafiklerinde bütün dağılımları ben buraya koymadım. Çünkü bunun sebebi çok fazla, yani 5 tane dağılımı buraya koyduğum zaman görsel olarak fazla belirli olmuyordu, ama burada şu an bunu kıyasladığımız zaman işte aynı şekilde Gaussian kernel dağılımının grafikte benim verime ne kadar yakın ettiğini kümülatif dağılımlarda görüntüleyebiliyoruz. Burada en kötü fit eden dediğim gibi Weibull dağılımıydı. İşte burada görmüş olduğunuz gibi işte CDF grafiğinde de böyle uzak kaldığını gözümüzde fark edebiliyoruz. Bunun haricinde bunu matematiksel olarak da kıyaslamak için işte dediğim Kolmogorov-Smirnov testini uyguladım. Burada Kolmogorov-Smirnov testinde KS istatistik değerleri bir kapasite oranı 0,5 ile 1 arasında her bir farklı istatistiksel dağılımın KS istatistik değerinin değerleri tabloda görüntüleniyor. Burada işte az önceki grafiklerde gördüğümüz Weibull dağılımının ne kadar yüksek sonuçlar verdi. İşte bu KS istatistik değeri ne kadar küçük olursa benim modelime o kadar uyumlu olduğunu söyleyebilirim. Burada Gaussian kernel dağılımı işte 0,1 gibi sonuçlar, çok yakın sonuçlar verirken Weibull dağılımı işte 0,9 sonuçlar vermiş, 0,7 hacim bölü kapasite oranında. Bunu sonuçlar kısmında biraz daha açıklayacağım. Şimdi burada verilerin incelenmesi konusunda burada her bir dağılımın gerçekteki verilere ne kadar yakın sonuçlar verdiğini kıyaslayabiliyoruz bu tablo sayesinde. Burada görmüş olduğunuz gibi KS değerleri
Son 3 dakika.
Burada tabloda görmüş olduğunuz her bir hacim bölü kapasite oranı için KS istatistik değerlerimi görebiliyorsunuz. Burada bütün dağılımların KS değerlerine baktığım zaman en iyi dağılımın her bir hacim bölü kapasite oranı için Gaussian kernel dağılımı olduğunu KS istatistik değerlerinden söyleyebilirim. Ama bunu şöyle de daha kolay izah edebiliyorum. Burada gerçek benim statistik ortalama değerim 0.5 ve 3.3142 iken araç takip aralık süren Gaussian kernel direkt bunu bu değeri bana bu model direkt bana bunu tahmin ederek direkt aynı sonucu verebilmiş. Burada bu non-parametrik bir modeldi. Parametrik olan modeller arasında da en iyi sonucu bana log normal dağılım vermiş oldu. Burada da işte görmüş olduğunuz gibi mesela 0.7 hacim bölü kapasite oranına bakarsak log normal dağılımın 2.3704 araç takip süresi sonucu benim ortalamamken log normal dağılım 2,3721 yani çok yakın bir sonuçla tahmin edebiliyordu log normal dağılım. Sonuç olarak arkadaşlar yapılan çalışma sonucunda Türkiye'de Ankara Eskişehir otoyolu üzerinde farklı trafik koşulları altında elde edilen verilerin seçilen istatistiksel modellere uygunluğunu araştırdım bu çalışma kapsamında. Yapılan KS testi sonucunda Türkiye'deki otoyollardaki araç takip süresinin tahmininde Gaussian dağılımının yakın sonuç verdiği ve en uygun sonuca ulaştığını tespit ettim. Non-parametrik olan Gaussian dağılımının farklı trafik koşulları altında yani bu V bölü C oranının 0.5 ve 0.7 aralığında en yakın sonuca ulaştığını ve yolun hacim bölü kapasite oranının artması halinde tahmin yakınlığının düştüğünü gözlemlenmiştir. Burada hemen bir geri dönmek istiyorum. Şunu göstermek istiyorum sizlere. Burada görmüş olduğunuz gibi 0.6 ve 0.7 hacim bölü kapasite oranında 0.01 KS statistik değeri verirken bu hacim bölü kapasite oranı arttıkça benim KS değerim Gaussian dağılımı için artıyor. Ama bu non-parametrik olan bir model olan Gaussian dağılımı parametrik olan diğer log normal dağılımlarda ise mesela en yakın olan log normaldi. Burada 0.5'te ve 0.6'da mesela 0.3, 0.4 iken hiçbir zaman bu hacim bölü kapasite oranı artmasına rağmen herhangi bir KS statistik değerinde yani modelin uygunluğu değerinde herhangi bir değişim olmuyor. Ben bu sonuca ulaştım sonuç olarak. Parametrik olan log normal dağılımın Gaussian dağılımından sonra Türkiye'deki otoyollarda trafik modellemesine yakın ve uygun dağılım gösterdiği belirledim. Parametrik olan dağılımların trafik modellemesinde farklı trafik koşulları altında tahmin yakınlığını değiştirmediğini gözlemlenmiştir. İşte az önce göstermiş olduğum gibi işte log normal dağılımın farklı V bölü C oranları arttıkça ya da azaldıkça herhangi bir değişim göstermiyor. Genel olarak seçilen modeller benim trafik modellerine yakın sonuçlar verdiği ve sadece Weibull dağılımının trafik modellemesine uygun bir model olmadığı sonucuna ulaştım. Bu çalışmamın sonuçları bu kadardı. Dinlediğiniz için teşekkür ederim. Soru sormak isteyen varsa sorabilir ya da sormak isteyen birisi var mı?
Teşekkür ederiz Mehmet sunum için. Sorusu olan var mı? Soru yoksa I'm going to skip the last presentation. Unconfined compression strength of the polypropylene fiber reinforced alluvial deposit by Malik Zada.
Yes, it's me. Hi everyone. Can you hear me, sir?
Yes, everything is okay.
Great. First of all, let me introduce myself. I'm Abdulrahman, studying my master degree in Istanbul University by permission of respectable teachers and participants. I want to start with just a minute. Let me share my screen first. Yes. Yes, the topic of my study is unconfined compression strength of polypropylene fiber reinforced alluvial deposit. And of course, my advisor is Associated Professor Dr. Hasan Polat. In this study, in this presentation actually, we will have four main parts. Introduction, I will talk about alluvial deposit and a little bit about the literature review, and then about materials and methods, then results and discussion. Of course, at the end will be conclusion and time for your questions. Let me start with the question. Why are the alluvial soil defined as problematic soil in civil engineering? Of course, we all, as we know, alluvial soil, they are problematic soils. The three main reasons for this problem and solution is because alluvial soil have low bearing capacity, they have high organic matter, and also they have high void ratio. They are the three main reasons that makes alluvial soil problematic in civil engineering. Of course, therefore, alluvial deposits should be stabilized using geosynthetic and geotechnical engineering for treating soil properties. Its advantages because they are cheap, economic, and also they are eco-friendly. Fiber reinforcement causes considerable improvements in shear strength and tensile strength and other engineering properties of soil. Of course, in this study, fundamental engineering properties, compaction behavior of alluvial deposits, and the influence of discrete and randomly oriented polypropylene fiber reinforcement on unconfined compressive strength of alluvial soil are presented. Let me briefly review the literature. 2005, Burak investigated the geotechnical properties of alluvial soil in Umarli, Istanbul, as you can see in table, the data. And also Çobanoglu and Bozdağ in 2007, they examined the index properties of alluvial soil in Adana, Turkey. In 2010, Yılmaz and Karacan determined the physiochemical consolidation and swelling characteristics of the sample collected from Erba Basin, Turkey. Also, Tan and their friends in 2004 made a series of subsurface investigation, including in situ and laboratory tests, has been carefully planned and carried out for the residential and commercial development over soft marine clay as Bukit Tinggi, Klang, Malaysia. In our study, in our case, there are two materials used in this study: alluvial soil, which is taken, which is alluvial soil that are used in this study were taken from Chile, Balachik region. Of course, it's from our school. The sample were taken from a construction site where is located at İzmir Çelebi University. Total exploration depth was 30 meters, and alluvial soil samples were taken for each 1.5 meter from boreholes. The samples were immediately coated with nylons and to protect its natural properties, and they were transferred to soil mechanic laboratories and kept in all airtight boxes. The second material which is used in this study is polypropylene leaf fiber. This fiber is an thermoplastic polymer produced from polymerization of the propene under 25 to 30 atm at 100 Celsius degree in the presence of a catalyst system. And you can observe the properties of this leaf in the table. I'm not going to read every one of them. About the method for index property, a bunch of tests has been performed: grain size distribution, plastic limit, liquid limit. Of course, they are done in the way which is given in United States classification system, ESTM, American system, and also British system, British standard. Also, organic matter content, a specific gravity pH of the alluvial soil is checked. Standard compaction test has been performed. Of course, the compaction properties of the soil can be defined by means of a standard laboratory test. The soil is compacted in a cylindrical mold using a standard compaction effort, as you can see in the figure. This is the procedure for compaction test, preparation of the sample and then performing the test. The reason why we did standard compaction, as I said before, I mentioned that we wanted to see the compaction behavior of alluvial soil, and also the maximum dry unit weight and water content is needed for performing unconfined compression test. That's why we needed to perform this test as well. The next test which is performed in our study is unconfined compression test. According to ASTM, it's a D2166. Unconfined compression. This test method contains the defining of the unconfined compressive strength of cohesive soil in the remolded, intact, or recomposed condition, using strength-controlled application of the axial load. As you can see in the figure as well, this is the procedure for performing this unconfined compression test, preparation of the sample, and performing of the test itself. In the result part, this is the idealized soil profile, which is gotten from the grain size distribution test. As we can see, from 0 to up to 27 meter depth of exploration, we can see the percentage of gravel, sand, and silt and clay in this study. In the other table, as you can see, for each depth, for each 1.5 meter, we got our liquid limit, plastic limit, specific gravity, and pH. As you can see here, it's up to 13 meter. Also in compaction result, the compaction tests have been done for 3 boreholes, borehole 2, 3, 4. And as you can observe, there are different maximum dry unit weight and water content for each sample. For instance, in borehole 2, you can see that maximum dry unit weight changes from 15 up to 19. The same thing happens for borehole 3. It's different. It changes from 15 up to 17. So it means the different boreholes got different maximum dry unit weight and different water content. And here are the compaction curves for compaction test. As you can see, for borehole 1, for borehole 2, borehole 3, and borehole 4. The other result is for unconfined compression test. Of course, by using maximum dry unit weight and water content, we performed our unconfined compression test, and we used 1% polypropylene leaf by dry weight of soil in our study. In this study, as you can see, the effect of polypropylene fiber, since it's 1%, it's not so much effective. And borehole 2 and the 1.5 up to 3 meter, as you can see in the first figure, we have an increase in stress. Of course, in unconfined compression stress, we have an increase. In the second one, we have a decrease. It affect negatively. In third one, it's like almost neutral. It didn't affect at all. So in here, let's make it like a summary. You can see the effect of polypropylene leaf, 1% of polypropylene leaf on alluvial soil in different depths. You can see the unconfined compression strength, which is unreinforced in its natural state, and also the unconfined compression stress for the reinforced. In most cases, it affects negatively, unfortunately. In conclusion part, I'm not going to read all of them. I want to just mention 2 or 3 sentences in the conclusion part. The positive part of this study is that it's observed that the failure of the fiber reinforced specimen occurs in longer time than the original soil, which indicates increase in the ductility of the soil using polypropylene fiber. Also using in literature review, as I mentioned before, polypropylene fiber is effective in tensile strength and in shear strength. We checked it on unconfined strength, which is in literature, most of the study shows that the maximum effect is in 0.75% of fiber. We used 1%. So if we use more than 0.75%, it can affect negatively on unconfined compressive strength, since in the study 1% of polypropylene fiber have been used. Using 1% or more polypropylene fiber can affect negatively on unconfined compressive strength of alluvial deposits. That's it. Thank you so much. And now, if you have any question, you can ask.
Thank you very much, Münir. Do you have any questions about study presentation?
I have a question, please.
Yes, sir.
Yes, sir.
Abdulrahman,
Yes.
do you use these types of reinforcements already in Afghanistan?
No, sir, not yet. I'm not sure if it's used, because geosynthetics are mostly used in recently years. Especially, as I said, it's used for tensile and shear strength. Since unconfined compression strength is important for us, especially in highways, so it's almost like it affected negatively. So using geosynthetic, or especially using polypropylene fiber, it's like almost not so efficient. So I'm not sure if it's used in Afghanistan or not, but we studied in here in this case. So we saw that 1% is affecting negatively.
Yes.
Yes.
Thank you.
You're welcome.
Any question? I think no. This was the last presentation, and this is the end of this session. I would like to thank all of the presenters and the presentations and the audience. This is the end.
Professor Altıntaşı, I also want to thank you for your contributions to our Congress.
Thank you very much.
It was a pleasure for us.
Thank you. Me too, and you. I think as a Katip Çelebi University, you have done a very good work by arranging this Congress in online. Thank you.
Thank you.
And give me an opportunity to give a sharing.
We thank you also.
Nice time for everyone.
Sanırım bitti. Kapatıyoruz.
Evet hocam.
Tamam.